If you can believe that.
Yeah, well,
It's true.
yeah, he was a mathematician, so.
Yeah, math professor.
But he was an 800-pound gorilla.
He's a professional activist.
Yeah, he was.
Oh, yeah.
Yeah.
I remember him well.
We're going to have a show about mass maritime.
Oh.
No, mass
Military
military. At the end,
It's a
great.
real problem in the Cape. Those interlopers from the Mass Maritime Academy taking over the anagrams that are too close.
Folks, mass military reservation. Well, you know, it's been over 50 years that people have wondered. Good things are happening on the base. You know, the country's being protected. All kinds of events are happening, and yet it's not just the news that's leaking off. There are chemicals leaking off, and also there's things that aren't leaking off, like unexploded ordnance and things like that. So we finally got the program we want. People are cleaning up, and as a matter of fact, there are excellent programs that are so good they are examples for the whole country on how this should be done properly. We have right now John Davis, and he's the Air Force part of the cleaning up, and that's what's coming off the base, I gather, in the plumes. And then we have Ben Gerson, who is with the Army, and what he's doing has to do with the groundwater program, and that involves the cleanup of the impact areas. And at the very end, we'll be putting on the websites. But before I introduce these guys further, I've got to tell you, you want to learn more information, these are the two best websites I've been to in a long time. They're going to tell you with good maps, good historical accounts, good information in terms of how the community has been involved over the past decade and more, what the current cleanup schedules are, and also what the ones are to come. It's an education that is amazing when you look at that, and whoever's done those websites really needs to have some, you know, high praise given to it. And it's very easy to get. All you have to do is to go to Google and say, groundwater program, Army, and wouldn't you think that the whole country would come up? No, it's the Mass Military Reservation, and that is the leader, I guess, in the groundwater program, right?
Yeah, we got there first.
You bet, you really did. And of course, mmr.org will always get you all kinds of great information about what's going on with the cleanup of all the plumes that over the years we've come to know more and more about.
That's right.
And so we have an opportunity, Brian, in order to be able to tell folks at this end of the Cape, because the people that live in Sandwich and Bourne and Falmouth and Mashpee certainly know all about what's going on because they've got good education there and people are tuned into that. But as you move over to the Mid-Cape and on the Lower Cape, we know about it, we care about it, but we don't know really as much as what's been going on lately.
Well, you know, a lot of it has to do with the ultimate question, what does it mean to me? Why is it important to me? And one of the things we were talking about earlier, which I think is critically important to all of us, particularly at this juncture in time on the Cape, is the science of understanding groundwater plume migration and groundwater hydrology. You mentioned that, you know, you guys were there first. Well, we have two, sort of cutting edge groups here on the Cape that were involved in that sort of stuff that impacts our coastal waters. The nutrients that are flowing from our communities having impacts on our coastal waters. Well, the science that we need in order to understand where that's coming from, where it's going, what's important, what's not important, comes directly from the information that we learned in dealing with those issues. And you know, it's kind of funny as we kind of look at the transition that we're going through at this particular juncture in time, we're moving towards that stewardship role. And I think that there isn't a group that represents the ethic of stewardship better than the team that's been at work at Otis at the MMR.
Yeah, and they're doing sustainability. They understand it. They understand community involvement. So Ben, what do you got to say?
Well, it's great to be here, and it's great to talk about the work that we've been doing. And like you said, that we've been studying the groundwater on the Upper Cape for a long time, and the problems were first recognized by the USGS and some of the work they were doing on the southern part of the base.
We said no acronyms tonight.
Okay, it's going to be a long one. United States Geological Survey is USGS, and Dennis LeBlanc and his team and the work he did in finding the very first groundwater plume on the southern part of the base, and it's just carried on from there, increasing our understanding of what the contaminants are, how they behave in the environment, and the best way to clean them up.
Geez, it must have been like being the guy who was responsible for draining the ditch in amongst all the alligators, during that period, because you were kind of chasing this elusive foe, which was the plume, and figuring out where's it going, how's it reaching everything, what's happening to it. During that early stage, it was kind of a challenging time.
Right.
Different now.
It is. It's advanced, and you think back to those early days, the 70s, when the first pollutants were seen in a town of Falmouth public water supply well, and it foamed, and they said, "What's this? It's a brand new well," and it turns out it's detergent from a wastewater treatment plant that was a couple miles up gradient. And you talked to Ben mentioned Dennis LeBlanc, who works for the Geological Survey, and he was a kid out of college then, and saying, plume wasn't really in the vernacular, and looking up and go, how could contaminants from there get to here? And he says, now it's just, we understand that off the cuff, but back then, it just wasn't the common understanding.
Not understanding that. It was so fundamental to everything that we're dealing with today. And it's not just Cape Cod. It's every community or coastal community around the country, certainly around the world.
That's right.
This is critically important information. It's exciting to know that's happened. Now, as far as the cleanup is concerned, what kind of stuff has been going on? Have we capped one of them yet? Have we gotten to that point yet, or is it? I know it's a long-term process, but how are we doing?
We always put it in terms of we're doing great, and there's a lot of ways you can look at and measure that and talk about it. One, of course, is dealing with the sources of contamination, whether it was a sump behind a building where somebody used to take solvents and where they were cleaning brushes maybe, and the common practice was to dump it down there, or a landfill, or storm drains, all fuel spills. All the source areas on the main part of the base are taken care of. And Ben will probably talk about the source areas up in the impact area. But you got to think, these are the places where the contaminants first hit the earth, rainwater carried them into the aquifer, then the aquifer flow carried those contaminants once dissolved in the water through the groundwater and off the base. So those source areas are taken care of now. We've had plumes that 10 years ago we mapped, and you could take groundwater samples and be able to draw an area where there was contamination, and that's where we call a plume.
Right.
We don't have the plumes there any longer. They're gone. We did active treatment.
Wow.
We shut off the treatment system. We can't even map a plume there now. We've got other plumes that are going to be there 50 or 60 more years, but we've removed 70 or 80% of the contaminant mass that was in the plume when we first discovered it. So it's a long-term process, but we've made great progress. All the plumes have active treatment, that are going to have active treatment. We have a few more wells that we're going to add to do some additional pumping, but that's where we say we have a measurement that's called remedy in place. And DOD, Department of Defense, wanted the Air Force and the Army to be at remedy in place by 2012. Well, we're going to make it this year. So 3 years before the Department of Defense goal. And for a site this big and complex, that's a great milestone to reach.
Pretty remarkable.
That's right.
Back at the beginning, kind of looking at it and thinking that, and again, reflecting on that way back, I can remember the Connies and so the airborne radar and all that sort of stuff, and the emergency fuel dumping, and
Don't pass over that too lightly, because I think anybody that's just come to the Cape doesn't realize that emergency fuel dumping. Well, what was that?
As he was mentioning,
that was an airplane coming in, and if it wasn't going to land properly, if it was going to have an accident, you didn't want to have any fuel in the gas tank, so you let it out, right on the base before you landed, right?
No, it was it was an emergency dumping of the fuel if you were going to go through a crash sequence.
Well, let me hear these guys.
You're thinking of an airborne aircraft?
Why am I wrong and why is...
Well, if you're airborne and dump your fuel, usually it vaporizes and you don't worry about the fuel hitting where I think the way the story goes, and from documentation, interviews, is there was a certain aircraft, it was the Constellation, that the wing tanks needed to be drained based on how much fuel was on the aircraft and what was going to be, how it was going to be taking off and what kind of load it had. So they just had this procedure at the end of the runway where they'd open the valve, let the fuel out.
At what point? In a takeoff procedure rather than in a fueling procedure, in a landing procedure? When did that happen?
That's when the aircraft obviously is stationary. It's getting ready to take off.
Pre-flight.
Pre-flight.
Pre-flight. Right.
Okay, and I am completely mistaken in my understanding of where that fuel dump came from.
Right.
It came from too much fuel being put in initially?
I don't know the exact technical procedure that would have led the maintainers to say we need to let some fuel out here, but the interviews yielded the information that sometimes they didn't need to let any out, sometimes a gallon, sometimes 10 gallons, and they started adding up how many sorties were flown and saying, boy, the potential fuel spill over the time that aircraft was flown was pretty large, and it ended up being called Fuel Spill 1, and we still have a residual plume from that fuel spill that has left the base and ended up in a cranberry bog in Mashpee.
Well, that's probably the reason why, some people say, well, why is the Air Force, why is the Army involved? Why are both of you guys here? And that's probably why, there were different exercises, activity regimens that were undertaken that were the sources of the original contaminants, and those were under the mission statement?
Isn't it really because there's an Air Force site, Otis, and then there's a
I don't know. Let's go ahead and fix this now.
Let's fix this now. That's a great idea.
And then there was the National Guard that was training in a different region in the
let's
I know. I think it's almost a good thing for you to understand that here I thought I knew something about environmental problems, and I obviously didn't have this thing straight at all. Right. So if I don't have it straight, just think of the public that hasn't really been trying to understand things.
Right.
How much do they understand?
Right. Well, the Air Force Army thing always comes up, and let's get that straight. The reason there's two of us is there's two cleanups going on under two different cleanup laws.
Yeah.
Ben is working under, you want to describe yours first and I'll describe mine.
My program is being conducted under the Safe Drinking Water Act, under EPA administrative orders. Geographically there's a difference. We work on the northern part of the base, and as you mentioned, this is the area that historically the Army used and the Army National Guard used for training. And the other difference is where John's program deals with more conventional contaminants, the fuel and solvents. We deal with less conventional contaminants like explosives and propellants and things like that, 10 or 15 years ago, the thought was that these weren't even contaminants of concern that could ever get into the environment.
Neither was nitrogen, might I add.
Couldn't even get into the environment. So this, we've been on the cutting edge of understanding how explosive residues on the soil can get into the groundwater and cause groundwater plumes, just like the fuels and solvents can do.
Wow. And then on the Air Force side, we're doing the cleanup under, we think we all know the term Superfund.
Right.
Yeah, that's what I was
The Comprehensive Environmental Response and Compensation Liability Act, created in 1981 to deal with old spills. We're actually funded with Army and Air Force funds, but it's being executed by the Air Force. And it just begins what kind of money you use. I'm using one type of money, Army and Air Force, but doing the Superfund cleanup. Ben is using another type of Army money and only doing an Army response under the Safe Drinking Water Act. And that's why there's two programs.
Wow.
So when I tell folks, more money, like this fiscal year we're in right now, more of my budget comes from the Army than it does Air Force. But somebody had to be designated what's called the lead agent. Who's going to clean this up for Department of Defense? And in 1996, it went from Air National Guard doing the cleanup to U.S. Air Force doing the cleanup. So that's how that all fits together.
You talked about the measurement, and how do you measure a plume? And a plume has a geometry. you know, when you look on a map, you just see a two-dimensional picture of a plume. But I guess you could also look at the depth to which the chemical has gone, and then see how it's infiltrating into the water table as well. So how do you measure all these things?
A good way to visualize it is if you think of the electric plant on the canal, and on a cold day you can see the plume of smoke coming from the smokestack. That's got 3 dimensions. It's got a length, a width, and a thickness. You just kind of turn that upside down. In the groundwater, you have an area of groundwater contamination that's got a length, a width, and a thickness. And we track that by drilling lots and lots of monitoring wells and taking lots of groundwater samples to see how deep the plume is in the groundwater, how far it's traveled, and what the concentrations are.
And you've got pictures on the website I've seen of where you have your test wells to continue monitoring them.
That's right.
Yeah.
It's an interesting process. You think about, you set up a drill rig and you poke through the ground, and we go through what's called the vadose zone. And that's where you haven't hit the saturated water table yet. And out at the base, it's typically 60 to 80 feet. Then you hit the saturated water table. And then you start taking a groundwater sample every 10 foot. You stop, set up the equipment, pull a sample very slow. You fill up little vials, and those go off to the lab. The driller pushes another 10 foot, takes another set of samples, and that it's called profiling, and that can go on for another 200, 250 feet until you hit bedrock. Then all those samples come back from the laboratory, and you go, oh, we didn't have any detections for 40 foot, and then boom, we hit 60 foot of contaminated water. Came out the bottom, it was clean again, and then we hit another 20 foot of contaminated water, for instance, and then down to bedrock clean. So you end up understanding that these plumes are like blobs. I call them potatoes in space, if you can imagine. The plume coming at you, you know, and it tells you, you have a little circle of contamination coming at you here and down here, or if you look at it from the side, it's some up here and some down lower. And it tells you the sources were complicated. And it's just not one spill that happened during 1 week. You know, it's over years it happened, and then as different rain events happened, that will drive the contaminants down. So it happens in spurts, and that's why the plumes become very complex. When you look at them in 2 dimensions, we just color them in as one solid color, but you start to look at it in a 3rd dimension, and there's a lot more complexity to it. And you have to understand that in order to treat the plumes. We haven't talked about even how we treat them yet, and that's just by putting a big well in the ground that pumps water out. And when you set the well, it's got slots in it, and it's at those positions where you have the slots in the well screen. You want those to be where the contamination is, of course.
Right, because that's where you want to pull it out.
Right, and what happens is you set up your well when you start pumping, is that saying year 1, and it's doing great. Well, 5 years later, the plume that was 5 years upgrading has now reached the well. Well, the well's not as efficient anymore. That screen may not be in the right place anymore. So you've got to go in, you can go in and block off some of the screen. So you're always looking at the plume. We call it adaptive pump and treat. We pump the water out, we run it through carbon, put it back in the aquifer or to a surface water body, but we adapt those systems both in where they're pumping and how hard they're pumping too, because you don't want to be pulling in all this clean water. We have an electric bill, $2.1 million a year, and you don't want to be pumping water that doesn't need to be pumped and treated. So it's constantly adapting those systems so that they're efficient, and that's the part that we're really advanced in.
We got a few questions that will come right after that. Okay. And of course, I'll let Brian have the one as to, and you need electricity. How about some turbines to give it? Yeah, as a matter of fact, why don't we take that one right up? Because I thought when I looked at the website back in, was it April or so, that 6 turbines were going to be put on the Mass Military Reservation, and there would be a very large one on the Air Force, and 3 or 4 over with your area. Am I mistaken in that recollection?
No, that's correct. We can let John go first because his
He's got the bigger one.
He's got the bigger one, and his will probably go up first. So.
We've got a full-size utility class turbine that's already under contract. We're using a Furlander. It's a brand in Europe, German, 1.5 megawatt, and it's being placed at the southeast corner of the base. And when it goes up this summer, probably in the August or September timeframe, it's anticipated to meet 35% of our annual demand. So it will not only, of course, save us money, But all our electricity now is generated by fossil fuel plants, and we're going to cut those emissions immensely. And it's the first time that we've been able to see where somebody is taking renewable energy and then using that energy to power an environmental cleanup. And those ties are now being made pretty strongly across the nation into what's sustainable cleanup. Integrate that into your thinking when you're examining alternatives for clean up the environment, because you certainly don't want to be causing more problems than you're fixing. And we started this project, it's been over 5 years ago, and getting through the process of a design, and environmental assessment, and then buying one, then of course you buy it and then say, yep, the lead time is 18, 20 months. The manufacturers aren't out there like a GE interested in providing a single turbine project.
No, it's a real bear. I mean, the whole marketplace is kind of a very difficult one to negotiate these days. If you're not talking more than 20 or 30 machines,
that's right.
Nobody wants to hear from you, and that's a real impediment. The growth in the industry has actually been kind of a detriment to the smaller project scope. And that's one of our unfortunate realities is we're more of a distributed application than the large wind farm kind of an idea, which is what the model is kind of set up to support.
But the smaller projects apparently is a market Furlander has been paying some attention to. We're able to get one out in Central Mass. They're putting up a pair of them. And Furlander is working on a manufacturing facility out west. I think it's Wyoming or Montana is what they're looking at. So dealing with our electrical use with the wind turbine, and we've done audits on all our facilities, had lower use light fixtures put in, look at our pumps, and what types of pumps and what types of controls we have on those, where we've added variable frequency drives.
Sure, VFDs.
And our first systems, if you wanted to slow down the water coming from a pump, you turned a valve. The pump is still sitting there using the same electricity. Well, as the VFDs came, the variable frequency drives came out and got a little more reliable, then we started adding them. You want to slow down a pump, well, you change the frequency of electricity and slow it down, your demand drops off, and a lot better way of doing that. So combining that with the electrical audits from Cape Light Compact, just like everybody else, they came through our facilities. The next thing you know, Rise Engineering shows up and is changing out light fixtures and everything. And
well, efficiency is really the first phase of alternative energy. It's the most efficient too. I mean, your biggest bang for your buck is improving your efficiency. Then once you're super efficient, going for the renewables. And geez, I like the idea of having the ability to sort of sequence to a degree. I suppose you can't really stop the presses when the wind's not blowing, but if you can cycle and coordinate your program so that you could duty cycle more effectively, then you could put more of your demand on your renewables, which is a really great thing to do.
And we each have a project manager on our teams that are have been really the leaders at the base concerning energy conservation. Started Rose Forbes for me and Paul Nixon for Ben, and started a base environmental committee. If anyone's familiar with the base, there's a dozen organizations out there, not all working under the same commander, and just said, look, let's all get together and start sharing this information. And so having that energy committee going now.
That's great.
And so Paul's project and Ben working on the wind turbines on your side, maybe you want to.
Yeah, we've been taking a little different approach. We have a large area of 15,000 acres where we have now, I think we have 5 treatment systems in place, quite far apart. So we've been looking at more of a distributed approach where we'd put 3 or 4 or 5 smaller wind turbines closer to the different parts of the base. We've been looking at size ranging anywhere from 100 kilowatt to 600 kilowatt turbines is kind of the range that we've been looking at. And one thing that's helped us out, and we're just waiting to understand the total impact, is the Green Communities Act, that with the net metering
big stuff.
Benefits that they have that can, I think, really help not only our program out, but the base as a whole.
Well, it's a much different marketplace. It's understanding it and trying to figure out the nuances of it is a little bit of a trick right now. But it's going to mean some very serious things. I don't know if understanding that, it means that someone who owns a generation capacity can get that electricity anywhere where they're consuming it within the service area of the DISCO, the distribution company. So that's means a lot. That means that someone who's interested in wind doesn't necessarily just have to have the acreage themselves. It can be something that can be a shared resource. Really does help, particularly with our unique geography and sort of lay of the land here. But that's a very exciting potential opportunity.
So you've got energy to get the pumps working, and so we're going to be talking about, first of all, cleaning up fluids, because in a sense, if you're pumping up contaminated groundwater and then cleaning it, I noticed that there were two techniques we were using, both charcoal graphite and activated graphite as well.
Yeah, what we use is...
and iron resins, too.
Right. Those are the two main approaches we take. We use granular activated carbon, which is the charcoal that you'd have in a Brita water filter or an aquarium filter to take out organic contaminants. Those work, that type of system works very well for our explosives compounds, the RDX and HMX, and those things are cleaned up very well using the carbon, but unfortunately it doesn't work on another one of our main contaminants, which is perchlorate, which is in propellants, rocket propellants, that type of thing. For that, we need to use an ion exchange resin, which is the same type of technique. You pump up the water, you run it through a big tank with this resin in there, and it exchanges the perchlorate ion, and chlorine comes out the other side. So,
yeah.
And
John's the perchlorate had been, sort of sticking in various health groups' claw, because they've said, that's one we have to be careful about, because we, at the time, didn't have a safety limit that everybody was agreed on. Now, how close are they to a safety limit now?
Fairly close. They're a lot closer than when you first started to find it, and there was nothing to go on. You'd get a result back of 1 part per billion, and you didn't know whether you should run away with your hair on fire or disregard it, because you had no standards to compare against. At this point in time, the state of Massachusetts has come out with a drinking water level for perchlorate of 2 parts per billion. The EPA has just announced, I think, a couple weeks ago, that they are issuing an interim health advisory of 15 parts per billion for perchlorate.
And where are you in the treated water at this point? Do you know? Can you how far down can you measure it?
We measure it down to about 1/4 of a part per billion.
Really?
So we have a pretty low detection limit.
That's really accurate.
The levels in our plumes are anywhere up to 400 parts per billion, so we have pretty significant levels of perchlorate, and we're able to clean it up with the ion exchange resin.
So this was a brave new world, really. I mean, when these programs were initiated, this was, I mean, you guys are the ones that are really, cutting the first
There's a term called emerging contaminants, and if there's an emerging contaminant, we probably found it first. So.
A dubious distinction.
That's right.
No, that's another one of those things the Cape is leading.
There's emerging in history, but there's emerging also geometrically too. But there are other words. I got to ask about these words, because I see them and they what do they mean? I mean, remediation. Okay, is that a word which is cleaning up, or is that trying to accommodate it and do something good along the way? What is remediation really? You see it.
In common terms, it's cleaning up.
It is cleanup being conducted by people with college degrees. So
you add another syllable.
That's right.
A lot of letters after the name.
Yeah. But it's an interesting question. What we think about are what we call our remedial action objectives.
Yeah.
Okay. And there's really just two. One, we want to prevent exposure to the contaminants.
Okay.
You can imagine the treatment plants don't prevent exposure. What prevents exposure is what happened starting 20 years ago and up until as recently as probably 6 or 7 years ago. And that's finding neighborhoods, once we found a plume, and then identifying, well, here's a neighborhood where all the homes are on private wells.
So
we need to change that. So we go in, lay mains, put in fire hydrants, and laterals to each of the homes.
And give them bottled water before you get it all.
Right.
the
Until
work
you get
done.
there. That's right.
Basically-
If you've determined there's an immediate endangerment,
But
that's right, the bottled water.
Truth is, it's just infrastructure.
That's right.
You know, I mean, you're providing community infrastructure.
That's right.
As a means of lessening the potential impact of
Well,
the plume.
it's cutting that exposure chain.
Right.
And so you do the hookups, but then you have a neighborhood, and say someone's got a well or builds a new house and they want to drill a new well. Well, they have to go to the Board of Health to get approval. So we got with each of the towns around the Cape, and they put into their bylaws at the Board of Health. There are different languages, but the idea is you just can't go sink a well. If you're near a plume, you can't put in a well. So those are called land use controls, and those are put in place, and that's what keeps the exposure from happening, because that's our number one concern, of course, is public health.
Yeah.
The other remedial action objective falls under the category of restoring the aquifer.
Right.
And
Restoration.
Okay, now that was the other R
Okay.
word I wanted to, and restoration is going to have two aspects. We'll come to the soil next, but yeah, the groundwater.
That's right.
Yeah.
And we have a remedial action objective it's a sentence that really it says, restore the aquifer to its beneficial uses in a reasonable time frame given the circumstances of the site. So that's telling you how hard you
By
need to pump this.
politicians.
How hard do you need to pump this plume? I mean, you could put in $100 million of infrastructure in a very small area, pump it very hard and clean it up in 5 years, as opposed to doing a tenth of the expenditure, and it might take 30 years. And that's that time frame. And when we're making decisions,
Where's the
that's where the
max?
community is really a part of the decision making, as we lay out different alternatives. Here's their cost, but here's their benefits. And there's no magic formula, unfortunately, to go into and say, well, you put in a number, the answer is build this. It is a give and take with the regulators. It's a give and take with the community. Then you've got real world constraints. Where can you build? You know, there's
Right.
neighborhoods,
Right.
there's
Or-
other
right.
infrastructure in
Or
place.
actually, where can you put the water that you purify? Because you may not,
Well,
you
there's
may
the
have
other
too
thing.
much water.
Plumes.
Well, put them back in the
You're
plumes,
creating,
or-
no,
everything
I mean,
background.
if you're creating a
right at
lens.
that point. Okay.
Yeah. Yeah, we use the water to help control, and it's part of the remediation process.
Okay,
you know, when we put
I see
water
that.
back.
And
Okay.
then there's the option of just, well, let it flow to the sea.
And we've got some of those.
Yeah.
Yep. And that.
And what is that called again?
Well, it's landfill 1. It's called natural attenuation.
Natural
Right.
attenuation, right.
And
yeah.
some people just, and they say it's the AFC two-stepper. That's the name of my organization, Air Force Center for Engineering and the Environment. But we had a neighborhood in Bourne, Katamet,
Yeah.
and we have a plume coming from our landfill.
Yeah.
It went under the base boundary, under their neighborhood, and they made it very clear, we don't want infrastructure in our neighborhood. We know the plume's down there, but we're on town water, so there's no health risk. Let Mother Nature take care of it and go to the ocean. We can measure it where it discharges into the ocean, very low concentrations, drinking water quality, but you know, other places, no, we're totally capturing the plume and not letting it go any further. So it's there's not a one-size-fits-all for the plumes. It depends on the stakeholders out there. And I use that word stakeholder, but I also call it stockholder, because you know, remember, those are people filling out their 1040s, paying for
Right.
this project.
Right. Ultimately, the
It's all
buck's got to come from
taxpayers.
somewhere.
Right, and we like to report back to them, here's the progress we're making, and doing shows like this is part of that. So it's that stakeholder-stockholder relationship that we try to maintain with the community. But words like restoration,
Yeah.
one of the community members at a meeting said, I'd like to see a
Rejuvenation
presentation.
too?
Well, we don't use that one, rejuvenate. But he asked, when are you going to be done? I thought, let me come back with a presentation. And so I came back, and the word restoration was one I had underlined and said, this is a qualitative term.
Yeah.
What is restore? The Air Force came here and said, we're going to make the Cape whole. Well, that's a qualitative term. It sounded good coming out of a
Sure, great.
politician's mouth at the time, but it's just, when is clean enough? And Ben mentioned the detection limit on perchlorate. What if they get it half again as low?
Well, you know,
As
this is-
chemists get a little better.
But isn't this a question? This is a fundamental question that actually we're asking everywhere. You know, I mean, what do we have to do? I mean, but it's funny, but you know, you guys are the canaries in the coal mine. You know, I mean, yes, you know, some of these issues, some of these contaminants, and some of the plumes are issues and compounds that we really need to keep an eye on, because you know they have some issues associated with them. But your need to deal with this was sort of leading the way to the point where now we're all recognizing that it's just a general issue that we all have to come to grips with. Right. And that's our impact on the environment. You know, what have we been doing? What are we doing? How do we mitigate it? And then to what point do we try to restore it? I mean, right. You know, at what is the magic line that we're trying to achieve?
And what are your resources in order to be able
there
to
it is. If you have unlimited
levels.
Resources, and you know, then you can do it.
Right.
But the question is, you know, what is the law of diminishing returns going to have to do with it?
And what are you going to take those resources away from in order to
absolutely,
do it?
because you know, there's no cornucopia anymore. That's the other reality that we unfortunately have figured out as well.
And that's exactly the next phase we're moving into with the community is, okay, we've gotten to the decision of here's where we're going to do the treatment.
Right.
Now it's decision trees that we can build to decide when are we done. Because there's going to be 2 stages to done. You're done pumping, you're going to have contaminants left. What do you have to measure to watch for rebound? Then when do you actually say the site is closed? And there's again, there's no magic check mark you can go down and say we're done. And so we're going to build with the community. What are the concerns they have? Because I mentioned the 2 stated remedial action objectives, protecting public health and restoring the aquifer, but there's a lot of unstated objectives also. One of them is just making the plumes go away so that when person A goes to sell their home, the realtor doesn't say, I have to give this to the potential buyer. Or the thought that no matter what you tell me about the contaminants, if there's contaminants in the area, I don't like them and I feel uncomfortable because I'm raising children in this home. And you can sit there and speak all you want about risk assessments and everything else, but those are very real perceptions that people have that go away when the contaminants go away.
Right.
But those aren't stated objectives, but they're unstated, and we all understand that those are realities. That's why getting with the community and helping to build those tools that we can use as we approach a plume towards the end of cleanup. We've always said we want to pump until the wells are no longer effective. Again, a qualitative term. What is effective?
Right.
Well, let's start to put some boundaries on that so we can apply some fairly consistent thinking, but can be adapted to those different. No size fits all the towns and all the plumes.
No, which is another thing too. I mean, you don't have to reinvent the wheel. You guys already kind of know from your activities what's going on out there. But you are ultimately going to end up with an area that is going to be restored.
Well, let's take one area, which is a military base, which is a training area.
Right.
And now I guess we can talk about a few other things with respect to ordnance. I mean, if you're going to detect metal, you're going to have some magnetometer or something like that. What do they use to go test this? And when we talk about remediation or we talk about restoration, restoring it so it'll be a state park? No. Restoring it so it'll be a training area for National Guard? Or, I mean, what is the objective there with respect to what the Army's doing now?
Well, you've touched on a couple of different topics.
Yeah, we only have 10 minutes.
That's right. One is, it kind of goes along with what the land use is and projected land use. And the Army National Guard has a lease to conduct training on the base until 2052.
Yeah,
so they plan to be there a while to conduct training activities. They're also aware that they need to maintain those activities need to be compatible with the environment and not cause any future problems. So they're watching that in what they do. Then you touched on the whole issue of unexploded ordnance, and we're cleaning up plumes in the environment now that contain explosives, but we've also got these unexploded ordnance out in the environment that.
And what are they? Are they hand grenades? Are they?
They're
bullets?
They're up to.
How big are they?
The biggest
like this, like this.
The biggest thing we've got is a 155 millimeter howitzer round, which is about that long. It's 155 millimeters in diameter, so it's about that big around, and contains somewhere in the order of 12 pounds of high explosive.
And a kid isn't going to come in there and pick it up and show and tell, say,
we hope not.
Look, class, what I found.
Yeah, we hope not.
You have to dig it up.
Yeah, there's a safety concern associated with that, but there's also a potential future environmental concern, because what happens when that steel casing
yeah.
rusts and the fillers that expose the environment. You know, some of the plumes that we have of RDX now contain, 40 pounds of RDX.
Wow.
So it only takes 3 or 4 of those 155 shells to equal what we see in some of our bigger plumes. So that's a future concern that we're working with.
You got to find them all.
We got to find them.
I mean, that's a heck of a thing, because errant around here and there, over 30 years adds up to a couple of rounds.
Yeah. The thing we have going for us is time. We think it'll take hundreds of years for these rounds to rust through. So because they have half-inch thick steel casing, and it takes time. So we've been using a bunch of techniques to find them. Magnetometers, which are fancy names for metal detectors that guys use on the beach, but we just have ones that are pulled by carts and things like that. We've even used metal detectors that are attached to helicopters, so we've been flying low over portions of the base with a big metal detector to try and find the areas with the most concentration of metal items. But one problem is metal detectors detect any kind of metal, so it could be scrap, could be a fence post, could be a 155 millimeter howitzer round. So
you spend a lot of time digging in unproductive pits
to try and verify it.
And you're attempting finally to turn the area into what? Because you do vegetation. You've got these robotics, I understand, so that you can go in and prune the trees, prune the grass, whatever you're doing, but not get blown up at the same time.
That's right. The robotics is something we've been doing for about a year now with help from the Air Force down in Florida. And the key there is to help avoid, wherever possible, human contact with these potentially very dangerous items. So they have things like bobcats and backhoes and excavators and rakes and things like that to go in and cut the vegetation first, and then go in with implements that they can dig with to try and dig, all done remotely, dig up unexploded ordnance, separate them from the soil, and dispose of them properly and get them out of the environment.
Well, that's such an interesting point, because it has a collateral use. I mean, and saving lives in many different theaters, especially today.
That's right.
That's good stuff to be doing. That's very valuable stuff.
Another valuable application for what we're learning here.
And for the soil, there's a way of decontaminating it by heating it up to 500 or 1,000 degrees, churning it around, as though you were going to make some super kind of mud pies at the end.
We call it the cooker.
What do you call it?
The cooker.
The cooker.
And about 5 years ago, we went to our major source areas that we knew of and dug out the contaminated soil and cooked it at about 900 degrees to burn off the explosives and perchlorate contamination in the soil.
How big is this cooker?
It's pretty big.
You can show it like this. It's kind of like in this.
It covers about an acre of land. We had an acre spot to set up and use it. So
you're not doing it by the shovelful. You're doing it by the dump truck full.
No, we were doing, I think, 100 cubic yards an hour was the treatment
throughput.
The treatment rate.
100 cubic yards an hour.
And we treated a total of 40,000 cubic yards of soil as part of this project. So. It was going 24 hours, 7 days a week.
It's not a flow system. It's you have to empty it each time before you start with a new batch.
It's a flow-through system. It's got a conveyor belt that puts it in a rotary kiln, and the soil goes off, and then the rest of it is just air emissions controls to scrub the emissions out of the vapors that come off the cooked soil.
How many of those are there in this country, I wonder?
There aren't many, but this, interestingly enough, all the equipment had wheels on it and was mobilized on trailers or being pulled by trucks and was set up and did its job.
Whereabouts on the base is this one facility?
It's no longer there. It demobilized a few years ago, and it was just about right in the dead center middle of the base is where we had it set up.
So that part is done.
That part is done.
Joel Feigenbaum once described that area when he saw it, and I quote just something from the Cape Cod Times, it's as though you went to the surface of the moon. I mean, is it that grim looking in terms of where all the shells have been blasting the sand and everything?
It's an interesting contrast in that in the center of the impact area, what Joel described as the surface of the moon is also prime habitat for a number of endangered species here in the state of Massachusetts. Because of the artillery firing that went on and the fires that happened there, set up a fire-based habitat with scrub oak trees and pitch pines that is a globally threatened habitat at this point.
Oh my golly.
So it's just all these twists.
And so the Endangered Species Act is going to keep you from using it or something?
That's another consideration in deciding how to clean up the middle of the impact area is, you could go in and dig up 30 acres and cook it, but you're also destroying 30 acres of this habitat in the process.
Clear cutting,
right?
And more so.
Clear cutting and strip mining.
Kind of the strip mining.
Right.
Well, now that they have the Plymouth people deciding to bring Hollywood to Massachusetts, I think they'll be using that as a location for some science fiction. Don't you think?
You can't walk through that, bro.
No, you wouldn't want to be
6 to 8 foot tall, and you can't walk 2 foot through it. That scrub oak is something else. It's,
Okay. Yeah.
Wow.
So.
Yeah, it is an interesting question. How much cleanup is going to happen on that UXO area? You think about it. Can the Cape? Is there still enough aquifer to provide water supply for the Cape? To me, that's a central question. And the regulators look at it a little differently. They say, well, it's a sole source aquifer. We should keep it all clean. So it's going to be that balancing again that I was talking about earlier. If some shells did open, you identify an area, don't put water supply wells here. There's still plenty of other aquifer to reach the build-out needs of the Upper Cape in terms of water supply. So it goes back, remember, restore the aquifer to its beneficial uses given the circumstances of the site. So given the circumstances of a certain area, you might say, it's not worth the money to try and clean up that plume. We're going to let it go to the ocean. And water suppliers, you need to look elsewhere. And DOD built a water supply system up there. 3 water supply wells, a tower. It cost $21 million. And then we tied it into each one of the towns. 6 million gallons a day capacity. I think it's permitted at 3 million gallons a day.
We read about that.
Yeah, they're using a little over 1 million. So that's just it was just DOD's way in the late 90s. They said, look, we don't know what's going to happen in the future, but we're going to hedge and we're going to build this system and be ready to supply more water to the Upper Cape if we find the problem bigger than we think it might be now. And that system's out there and run by the co-op. And so that's a key question. But other people, and you can understand their point. We grew up on the Cape. If we wanted a well, I could drive a pipe, depending on where I live, by hand and get water. I should be able to do that whenever I want. It's a very valid point. And that's that balancing thing that we have to do with the community. You just can't look up the law and say it says to do this. The law says you work with the community in these decisions.
We're becoming urbanized. It's a totally different game. Than a rural environment where you can do that sort of stuff. You don't have to worry about that. Now everybody's, we're pretty close to each other. But being pretty close to each other, there's a serious issue associated with, having a neighbor that doesn't take things seriously. But that's not the problem with the MMR, which is something that's really exciting to see. And not only is it a beneficial neighbor, but look at the stuff that you guys have done to help us to deal with all these other issues that we're trying to wrestle with even today. We're still trying to trace that moving target. Of what point are we trying to get to? But at least we know where we've been, and we can look back and say, boy, we've done a lot. I mean, look at the accomplishments you guys have done. I mean, we're not doing the cooking of the soil anymore. We've gone through that phase. We're working towards bringing things back to where it's supposed to be. It's great stuff.
Yeah. Well, there's also the interdigitation of all the agencies that have to be connected. I mean, when you look at towns, 4 different Cape Cod towns getting together. Wow. Okay. Then at the county, you've got various agencies there, health, and then you've got the Cape Cod Commission sitting somewhere, and then you've got the state, and you've got the different federal agencies. How does that all work together? How do you do that with
How long's your show?
Yeah, I mean, how many years? How many years? I mean, that
Yeah,
was not a
with-
simple
with
process.
town- with-
It was
with
pretty
towns.
messy at the
And
beginning.
I didn't get down to the citizen level and the community level.
Well, yeah, but,
where they're not all. I
when
mean,
you talk about Joe,
yeah, one,
you know,
one
I mean,
town
you know,
doesn't
it's-
come in united. You've got groups
exactly
and towns.
different
too.
neighborhoods.
Who's in charge of all that public relations?
Yeah, I've got a full-time public affairs person. He normally takes calls from realtors and people
Yeah.
concerned. I read about this and sets up. But each one are the project managers. I manage some of mine. I've got a couple of people on staff. If we go in a neighborhood just to drill a well, we have to think about: do we need an easement? Do we need a license? What are neighborhood concerns? They don't want to hear the noise. We're trying to find a place just to drill a well. Then you think about: we've got over 20 miles of pipeline that's off base. I've got probably $2.2 million in easements out there where lay pipes, pumping wells, transformer boxes, all those sorts of things. And it's really, there's nothing better than walking up to someone's door and just talking to them. And then they grab a couple neighbors and then say, hey, why don't you come back and talk to us? We've got the neighborhood together. And some places you need to go down to town engineering and talk to them, or go to the Board of Health. You've got to know your selectmen. Try to get in there every year, update the board on what's going on. And it's just keeping those contacts going. And in the regulatory system, that's pretty much set. The one interesting fact I have to bring up: the Air Force takes a batch of money, gives it to the state, and pays the state to regulate us.
Try that again.
It's a program that the DoD set up
But
with.
regulating on what basis? On state statutes?
No, on what needs to be done.
Well,
Well, that's right. The state.
there's a contract in a sense.
Almost.
Yeah.
We don't put in the terms of regular contract terms,
Yeah.
but we do lay out, here's what we think is going to happen the next 2 years. Here's the estimated cost. Give them or assign those dollars, and then they invoice the DoD to get return funds on regulating us. But looking at what regulations apply, it's called other applicable. There's a term for it, but it's applicable or not. And we have an agreement with EPA that here's how DoD is going to conduct the cleanup. The state did not sign up on the agreement. They reserve their right to still look at the way EPA and DoD decide to do a cleanup, and they still have their own cleanup law. We intend to meet that as we do the cleanup, but they reserve the right at any time to come in and say, no, we don't like the agreement you made with EPA. We're going to have you do this under our own cleanup law.
Environmental Protection Agency is a federal.
That's a federal
right.
agency.
Yeah,
That's right.
Right.
And does the judicial ever get into the act? Because so often with all the environmental things that go on, you know, there's always the courts that one
Right.
can go to.
We've had a few court cases. We had a neighborhood that thought they should get water hookups or get reimbursed for water hookups.
Yeah.
They filed a claim. We have one plume that we believe was caused by a privately owned pipeline. We've been paying the cleanup, so Department of Justice is involved trying to get this other private party to pay for the cleanup. It's been going on for 14 years, but that's the nature of things. And the cleanup's up over $50 million for that one plume, so you can imagine the group we think is the potentially responsible party isn't just going to, I'll get my checkbook and take care of this for you. So it's been an ongoing.
Yeah, and we've had defense contractors conducting operations and testing at certain parts of the base that resulted in soil and groundwater contamination, and so we've worked with Army and Justice folks to go after those contractors to get compensation back for the costs that we've put into the cleanup.
Well, you guys seem to be doing the precautionary principle from a standpoint of looking at what the potential impacts would be and proactively dealing with those up front. You know, the idea of saying, okay, if we're going to be doing this, then the state's going to have to do this, this, and this. It's going to cost money to have that done. Here's the budget, which is really sort of an interesting way to deal with it. But it seems to be kind of the way you're dealing with all of the different issues that are associated with it. You use some vision to see what could be, come up with a plan to do it, and take action.
Right.
The water systems are exactly like that.
And Brian, with our new president, I think transparency, and
Right.
I think there has been transparency which wasn't present
In
way
the
back
early
when.
years, that's right.
And so it's that transparency, I think, that really has made the big difference.
Yeah, it's funny. I was on
And
the,
education.
right. I was on the phone with someone today, and he said, "There's a well near my house. I'd like to know that data. I know you can't tell it to me." I said, "Give me your email address." In 10 minutes, I went to the database, downloaded the data, said, "Here it is," and gave him a few sentences on here's what it means. And You know, people are thinking, you're not going to tell me what the groundwater results are near my house. Of course, you paid for it. You know, nothing better than sitting down and talking to someone about what's going on out here.
Yeah.
So we've come a long way in that regard, transparency.
I thank you for the education that you've given the viewers. I thank you for the education that you've given me tonight.
It's truly been a pleasure.
It's been great. John?
Thank you.
Ben?
Pleasure.
Thank you, sir.
Thank you.
Thanks, Brian.
Thank you very much.
Okay,
Yeah.
you're welcome.
It was indeed a pleasure, and I thank you for all the good work that you're doing and for helping us with these important issues that we're all trying to wrestle with.
Yeah, we've given
Great
you a little
stuff.
publicity, but I think the Cape Cod Times really does you guys really well. Thanks
yeah,
for watching, folks. We'll be seeing you again.
Thanks.
Yeah, you get some really good articles going in there. I was trying to say, what was that?
The
one?
tone has changed over
Yeah.
the years.
Well, it has, but
Getting
I think the reason it has changed is because you've been effective in the way that you handled it. You know, very, very, very consistent. You've really gone overboard with trying to help people understand and holding public meetings, inviting people over, and you know, just continually, you know, taking the you know, let us help you and show you what we're doing.
Are there public school examples of the kids coming in and getting educated? Yeah,
That's how we go out to the schools.
Yeah, we really send on that. You know, it's education from.
Well, that's what it's all about. But you know, to see the real value, and matter of fact, I was just today I was talking to folks about nutrient plumes from the towns of Barnstable and Yarmouth, and what are the real ranges on them, and you know the different models and different